How well do you think you know your facts about derivatives? Well, let's put that to the test with this AP Calculus question from 2019 in question 6, part C. So we have here, I've heavily modified this question because there are 4 different parts to this. I think I'll do another one of the parts of this question in a separate video. But there's a lot going on, a lot of unnecessary information that I'm putting only what's necessary here. So just keep in mind that this is very modified. So we have 2 functions that we're dealing with, f and h. They're both twice differentiable, so you can take the derivative of it twice. And we can evaluate the limit as x approaches 2 of h of x using L'Hopital's rule. They want us to use that same limit, to find f of 2 and f prime of 2. And also, we know that h of x is 4 whenever x equals 2, but it's for every other point, it is x squared minus 4 divided by 1 minus f of x cubed. So a lot of weird stuff going on, and they want us to use all this information together to find f of 2 and f prime of 2. So let's first look for f of 2. So f of 2. Okay, so what are we going to do? Well, what we can think of is trying to use this fact here to help us find what it should be, but it's unclear what we're supposed to do. Now remember that they give us information for a reason, and maybe the thing that's kind of strange that may jump out to you is the fact that we can evaluate this limit using L'Hopital's rule. Why would they mention that to us? Well, if you think about it, let's say we were, we were trying to find the limit, and we realized, like, okay, anytime you have a L'Hopital's rule situation, you either have to have 0 over 0 when you try to evaluate the limit, or infinity over infinity. And so we can see if we can try to find which version that is, and then be able to figure out the rest. Now luckily we do have h of x here. So if we try to evaluate this function for x approaching 2, we can try to see what's going on. So let's see. So we can write that the limit as x approaches 2 of h of x is simply just the limit as x approaches 2 of x squared minus 4 over 1 minus f of x cubed. Okay, and now we can evaluate this using L'Hopital's rule, which tells us that we can differentiate the top and the bottom. But we don't actually totally have to do that. What we can do is try to see we're trying to see what situation we have. Is it 0 over 0 or infinity over infinity? So let's try to evaluate each one of these. So the limit as x approaches 2 of just the top, so we have x squared minus 4, well, what is this? So we can simply plug in 2 in this case, so we get 2 squared, which is 4, so 4 minus 4, and that is equal to 0. So the limit of the numerator is 0. So that means that the limit of the denominator also has to be 0, because that way then we have that 0 over 0 situation that enables us to actually use L'Hopital's rule. So we can find here that the limit as x approaches 2 of 1 minus f of x cubed, a lot of parentheses going on there, that's going to be equal to 0. So now what we can do is try to work with this a little more. If you remember your limit properties, we can kind of separate this we can separate this into the limit of 1 minus the limit of f of x cubed. So here we can take limit as x approaches 2 of 1 minus the limit as x approaches 2 of f of x cubed. And what we can do further is take the cubed out. What we can do is do this. We can take this limit and then cube this, okay? Because technically cubing is like a continuous function in a way because it's an exponent, like an exponential. And so we can use these properties to help us. So yeah, and like cubing, we can just take it out just because like I said, it's a continuous function technically, which is kind of weird, but whatever. And so then, yeah, what we can then do is notice that this is going to be equal to 0. And the limit as x approaches 2 of a constant is just that constant. So I'm going to put this up here. So what we get is 1, and I'm going to move this to the other side. 1 is equal to, well, the limit as x approaches 2 of f of x. What would that be? Well, we can't really do much with that, but we can do one thing. Remember that f is twice differentiable, which means it's differentiable, right? If we can take the derivative of it twice, then we can certainly take the derivative of it just once. So it's differentiable. And if it's differentiable, then it's continuous, because differentiability implies continuity. And so we know that f of x is continuous, which means that the limit as x approaches 2 of f of x is going to be equal to f of 2. That's kind of one of the defining properties of continuity. So this tells us that 1 is equal to f of 2 cubed, because remember we have to cube it. So 1 is equal to f of 2 cubed. Do we know anything else about f of 2? I don't think so. So actually, well, what we can do now is just say if we take the cube root, essentially we just get that, I'll just take the cube root here and then the cube root there, and then what we get is just 1 is equal to f of 2. And that's it. So we found f of 2. That was weird. It was definitely a weird way to get there. And f prime of 2, it's probably a little more straightforward, but we can see. So now if we want to find f prime of 2, make that prime a little better. There we go. So now, what do we need? Well, we could try a similar approach, but the thing is we need to somehow get a derivative of f somewhere in there. What if we actually did use L'Hopital's rule? What if because remember we were talking about doing it here, but then we said stop, just we can just figure out, that 0 over 0 situation. What if we actually did evaluate the limit using L'Hopital's rule? Because then we'd have to take the derivative of the top and the bottom. And if we're taking the derivative of the bottom, then we will end up with an f prime somewhere. So let's do that. So let's just basically do the L'Hopital's rule here. So I'm going to say that the limit as x approaches 2 of h of x is equal to, so we're still doing the limit, so limit as x approaches 2, but now let's actually do some differentiation. Sorry about that. So x squared minus 4 is just going to be 2x. Okay, and then the derivative of that, and then the derivative of this, so 1 is just a constant, so that's 0. We still have that negative, and we can use the power rule here, so negative 3 f of x, and then we're going to square that, and then multiplied by f prime of x, just because of the chain rule. And so yeah, so that's pretty much it. So the limit as x approaches 2 of h of x is also equal to the limit as x approaches 2 of 2x divided by negative 3 f of x squared times f prime of x. It's a lot going on there, but we can reduce this a little bit. So now what we can do is actually plug in x equals to 2, because each of these, the limit we can take, so the limit of a product, we have multiple things that we're multiplying here and dividing and everything. So the limit of a product is equal to the product of the limits, okay? So we could technically separate each one of these parts out and take the limit of them separately. And each part here, there aren't any problems with being able to plug in the 2, so we can just do that. So what we end up with is, so we're not doing limit anymore because we're actually plugging it in. So on the top we have 2 times 2, and then on the bottom we have negative 3 times, well, we're doing that now that we're plugging this in, so we have f of 2 squared. Well, f of 2 squared, we know that f of 2 is just 1, so 1 squared multiplied by f prime of 2, and that's exactly what we are looking for, so f prime of 2. Okay, so now what should this be equal to? Well, notice that, we took the limit as x approaches 2 of h of x, and we want it to kind of equal h of 2, right? And that would make the most sense in terms of like continuity, because we know that h is differentiable, which means it is continuous. So that means that this limit here, this limit function should approach 4 at x equals 2. So this will actually just equal 4. But now we have this sort of function here that we can, this equation I mean, that we can solve. So what we can do here is, I'll just do it this way. So then what we get here is that 4 over negative 3 f prime of 2 is equal to 4. And then we can divide both sides by 4, so we get this 1, and then here we get 1. And then what I'm going to do now is flip both of the fractions. So basically just take each to the negative 1 power. And then we get negative 3 f prime of 2 is equal to 1 over 1, which is just 1. And then we can divide both sides by negative 3. So we get that this is negative 1/3. So f prime of 2 is negative 1/3. So f of 2 is 1, and f prime of 2 is negative 1/3. So that was a long process to get there. And I don't know, this was really hard. I even, I was staring at the answer key, just trying to make sure I understood everything. This was hard. This was very difficult, and even after learning about it, it may still take a few times to actually let it sink in, like, why are we doing each step? But, it's just how it is. So this was definitely one of the more challenging AP problems I've seen. So, I don't know, hopefully if you were able to follow along, I'm happy about that. But if not, just ask me a question in the comments, and I'd definitely be happy to answer that. So, hope you guys enjoyed. Thank you so much for watching, and I'll see you in the next video. Bye, guys.